Okay, Brooke. Brooke is sick. Okay, we have 3 infected people.
It's time to make our own coronaviruses. It's time to welcome Dr. Stacey Finley.
So, one thing that I use math to try to understand is reactions that are happening inside of cells. So, you know that our body is made up of all different kinds of cells, and inside of every cell is a whole lot of different molecules that can combine together to make new molecules. So, this is just one example of a set of reactions that happen inside of cancer cells. And these reactions actually help the cancer cell to get oxygen and to get vitamins and nutrients that the cancer cell will need to grow. Just like any normal tissue in our body, just like we have to breathe in oxygen and we have to eat good food so that we can have the vitamins that we need. Similarly, tumor cells, which we don't want them to grow, they still need to get oxygen. So we want to know in our lab how we can go from, species or molecule number 1 to molecule number 2 and so on. And maybe with the mathematical model, we can try to understand what will happen if we turn off a reaction in this whole pathway. So if you just look at the pathway, like all of these different conversions, these chain reactions from one molecule to the next, you wouldn't be able to guess what would happen if I turn off this reaction just by looking at it. And that's why we need a model to help us predict what will happen if we turn off a reaction and how that will change how big the tumor can grow. Okay, so now I'm going to show you, let's pause it first. So I'm going to show you this video, and what the video is showing is some predictions from our mathematical model to see how large this model inside of the computer of a tumor, how large the tumor will grow. And so just to help you understand what these different colors are, so the blue colors are tumor cells or cancer cells that are not really doing anything. They're just kind of quiet. They're just standing by. The green cells are cells that are growing and moving around and getting bigger and turning into more and more cells. And then the red cells are dead. So they're called necrotic, but it's just a special word for dead cells. So we can put some equations inside of a computer and then predict how big this model of the tumor will get. So let's press play and we'll see how the tumor is growing. So you can see over time, the model is predicting that the tumor gets bigger and bigger. We see some changes that some cells are turning from green to blue. And eventually we're going to see some cells die, right? So they're the red cells, they're dead. And so some of these tumor cells are first moving around and growing, and then they start to die. So one reason that they start to die is because they're not getting all of the vitamins and the nutrients that they need to grow. And so we can look at, again, what's happening inside of this cell and see, well, if we change a reaction or we turn off a reaction, how will that change how big the tumor will get? Okay, so I want to go through an activity that will help us see how useful a model can be. So what we're going to talk about is the spread of virus. And I know that everyone in the Zoom room knows what a virus is. We're probably at home right now because of the coronavirus. And so in this model, what we're going to, first we're going to act out the spread of coronavirus. So this is just for pretend. No one in the room has coronavirus and it's all on the computer, but we're going to see how fast, if it's just, so we have 9 people in the room, I don't know if Daniel's here, but we have 9 people in the room. And so we're going to see how fast does a virus spread if we start with just one person who is infected. Okay? And so then we're going to put all the numbers in our spreadsheet and we're going to make a graph. And then we're going to see with a mathematical model if we can predict what happens to the number of sick people, the number of people who could get sick, and then the number of recovered people. So let's. And so what I'll show you is the model predictions for how the number of S, so those are people that could get sick, it looks just like what we were starting to see in our real life example, where it starts high and then eventually goes to 0. And then the number of infected people, that's purple, it starts low and then it increases and then it eventually goes back down. And then the number of recovered people, the people who are getting healthy after they've gotten sick, it slowly goes up until at the end, after a long, long time, everyone is recovered and no one is sick and no one can get sick. So in this model, once you get sick, you can't get sick again. Once you recover from your sickness, you can't get sick again. So there are some things that we could do, right? If we want to say, well, let's reduce the number of sick people. That's the I, reduce the number of sick people. So one thing that we could do in our model is to do quarantining. Does everyone know what quarantining is? That's what you're doing right now. You're trying to stay away from people so that you can reduce the number of infected people. Another thing that we're probably hoping we could get eventually for the real coronavirus is a vaccine. And if you take a vaccine, then maybe it will help you not to get sick. So these are different changes that we could make to the model.
I did a person not covering their mouth with another person.
What is that?
It's a germ that can get bigger and spread to other people.
Awesome. Very nice.
So this is a germ, and it's someone sneezing, and they spread out the germ to another person.